Hey everybody, let's go ahead and finish up Unit 3B for us. We're going to talk about how trig works and something called polar coordinates. So we know we've been dealing with rectangular coordinates and different ways that we can see rectangular coordinates, x comma y. But now what if instead of rectangular coordinates we had circular or polar coordinates where we look at this and you can kind of envision that it's a location like an x comma y, but we're dealing with angles and circles instead. So what we know about polar coordinates, let's go back right here. Polar coordinates are going to be listed instead of x comma y, we say r comma theta. That means the radius and the angle. Okay, so where we look for that location is what radius from the origin or the pole. Okay, the origin is at 0, 0, that's right here. Okay, right here, that's your origin, just like before. And then, so let's say we're looking for an angle. So let's draw an angle. So if this is our angle theta, we know if along this theta, here's 1 radius, 2 radius, 3 radius, and 4 radius, and so on. Okay, so the radius is the length from the origin, and theta is the direction from that standard point. So that's this polar axis, okay? So for example, we want to make sure if I know r comma theta, what we're going to do is I'm going to say, okay, where is pi over 6? Well, I know it's right here, so it's along this angle, and I want to know, hey, where's a radius of 2? So starting at the origin, I know it's positive 1, positive 2 towards pi over 6. So it's this point right here. Let's look at this one. So again, if we have r comma theta, let's look for 7 pi over 6. And that's right here. So now remember, if it's 7 pi over 6 positive, is going to be from the origin towards 7 pi over 6. But notice here that we're dealing with negative. So instead of being towards 7 pi over 6, negative 7 pi over 6 is going to go away the opposite direction from 7 pi over 6. So here's 7 pi over 6, and negative 3 is going to be over negative 1, negative 2, negative 3, away from 7 pi over 6. So the negative versus positive also tells you where we're at. Notice, if you look here, they're interestingly along the same line. So what if we wanted to name this point here not just one way, but 4 different ways? So let's look at that. If I'm going to look at this the first way, I know this angle here is 5 pi over 3. Whoops, what's happening? Sorry about that. So one way we could name this is, if I'm knowing it's here, I know that's along this line 5 pi over 3. So we could say, okay, if it's r comma theta, we could say that theta is 5 pi over 3. And since we're going towards it, we could call this 1, 2, 3, 4, a radius of 4. The other way we could name that, because if this is 5 pi over 3, that's from here to here, right? What if I wanted to name this going in the negative direction? So that theta could also mean negative pi over 3, right? So we could say, hey, theta is negative pi over 3, but it still is positive 4 because it's going towards that angle. So let's see if there's 2 more ways that we could name this angle. So remember, that's positive 4 if we're going towards it, but what if we wanted to use a negative radius? So that would be meaning that we'd have to be going away from the opposite angle. So if this angle is 2 pi over 3, going away from this angle here would make it negative 1, negative 2, negative 3, negative 4. That's 2 pi over 3 going this direction. Or negatively, we could go from here all the way around. We could call that same location negative 4 pi over 3. Okay, so for our angle, we could call this negative 4 pi over 3. And also because it's going away from it, that's also negative 4. Now, these are not the only 4 ways. We could rename these angles in an infinite amount of time. So this is just 4 of the infinite number of ways that we could name that polar coordinate. So let's convert polar to a rectangular coordinate. Remember, so rectangular is x comma y, but polar is r comma theta. So how do we go from r theta to x comma y? Well, remember, I'm going to put this over here in the margin. Remember that when we were talking about any theta along the circle, that I can draw this as a right triangle. Well, I know this distance is x, this is y, and this is r here, right? Well, in order to find this value of x, I know I could take the distance of r times the cosine of theta. And then also for y, I can take, well, that's r times the sine of theta. So this is where we get our formulas to get back to that rectangular form. So if I wanted to convert this polar to rectangular, we have to remember that this is polar. This is r comma theta. We want to know, what does this equal to as x comma y? So we're going to use our formula here that x equals r, which in this case is 6, times cosine of theta, which is pi over 3. So here we know cosine pi over 3, if we use our charts, as easy as 1, 2, 3, 3, 2, 1, we know it's positive root 3 over 2 in that first quadrant. And this will simplify to 3 root 3, and that's our x. And for y, we know it's r, which is also 6, times the sine of pi over 3. Well, we know the sine of pi over 3. Oh, whoops, I messed up on that last one. Pardon. I wrote down sine instead of cosine. Sorry. This should be 1/2. Okay, so 6 times 1/2 is still reduced to a 3. Pardon me. Please make that little adjustment in your notes. And then here I know sine is the root 3 over 2, which reduces to 3 root 3. So that point, x is 3, comma y is 3 root 3. Okay, let's look at this one. Again, this is polar, so this is your r theta, and we're looking for xy. So x equals r cosine theta, so let's plug that in. R is 4 times the cosine of 5 pi over 4. Remember, 5 pi over 4 is in the third quadrant, so cosine of 5 pi over 4 is negative root 2 over 2. This reduces, and we get negative 2 root 2 is x, and y is our sine theta. Well, we know also sine is negative here in the fourth quadrant, so 4 times the negative root 2 over 2 is going to be the same value because they're the same numbers as before, so negative 2 root 2. All right, so if we can know how to go from polar to rectangular, let's see if we can go back again. Let's go from rectangular to polar, specifically where the circle is just within one circle, so it's restricted. We don't have to worry about forever. So just like we had before, that same angle, okay, we have theta, and we had x and y and r. Remember that if I know x and y, I can know r. Remember, that's basically just the Pythagorean theorem, right? So we can say, hey, r is going to be the square root of x squared plus y squared. And then theta is like saying if I know x and y, that's this having the opposite and adjacent sides. So I know that's the inverse tangent of y over x, or working the tangent backwards. So let's use our rectangular coordinate xy, and we're going to find it in polar. So we want to know, what does this equal as r comma theta? Okay, so here we go. We're going to use our formulas knowing that we have x and y. So r equals the square root of x squared plus y squared. And we've got 9 plus 25, which is the root of 34. That doesn't break down, so we're going to leave it just like that. That's our radius. And theta is the inverse tan of y over x. Okay, you can use your graphing calculator, your calculator, make sure it's in radians. Just remember that inverse tan in your calculator only gives you values from the first or the fourth quadrant. So when it gives me that tangent in my calculator is negative 1.030 rounded to this. So remember, that's going to be here in the fourth quadrant. But if we're really looking at negative 3 comma 5, remember that negative 3, 5 would be negative 3 up 5. It's going to be in the second quadrant. So if we know this, how can we get it here in the second quadrant? Well, I can go from that negative 1.030 and I can add pi. So let's add pi to it. So I'm going to add that pi in my pi key in my calculator. And this rounds to 2.111. So I know theta is going to be 2.111 radians. Let's look at this one. So again, we have x comma y, and we want to know what r comma theta is. And then we're going to go ahead and finish this up. So we've got r equals the root of x squared plus y squared equals the root of 4 plus 36, which is the root of 40. We can simplify this down to 4 and 10. So this becomes 2 root 10. So let's leave it simplified. And then theta is inverse tan of y, which is negative 6 over x, which is 2. You're going to plug that in your calc, and it reduces, or it gives me 1.249 approximately. So remember, inverse tan gives me the first and fourth. That this is giving me, it's here in the fourth quadrant. And if I look here, let's just confirm, over 2 down 6 would give me the fourth quadrant. So I don't need to do anything to change this. This is indeed my, except for it's in the right location, but this needs to be positive 0 to 2 pi, and this is negative. So we're going to actually have to go from here and add a full circle of adding 2 pi to it. So let's add 2 pi to that in my calculator. And if I round that, we get 5.034. And so that is my angle.